presentation doc, or
From yeah, when you click on the link, it's already working.
okay.
Is it? Yeah,
Uh,
it's already working.
there it is in the chat also.
Hmm.
And that also means that the presentation doc is successfully shared now. And it looks like someone hit record for me. Thank you, whoever did that. I was supposed to do that, and I forgot to. Whoever set up record, when we're all done, could you email me the link for that so that I can forward it to the tech people? Okay, I'll assume that's a yes. So here I'm gonna switch over to presentation mode.
Okay, it's recording.
Cool. Who started the recording for us?
I don't know. It's just when I was about to start the recording, but it says stop recording now, so somebody's recording.
Yeah. Awesome. I appreciate that. Whoever started the recording will probably get the link to it in their email. So please forward it to me when we're all done. So I should be in presentation mode now. And so here we go. So there's a link again. So home screen, I'm gonna just go ahead and click to the next screen. I asked you to share in the chat in this slide, but I decided I'd rather hear your voices and maybe even see your faces instead of just the chat line. Hey, Steve, out there, can you monitor the chat window for me and let me know if questions come up that I should answer?
Yes, no problem.
Thank you, Steve.
Uh-huh.
So first of all, I wanted to talk a little bit about why I do these workshops. I've been going to the tech workshops for a long time, and learning about a variety of things, and I always thought it'd be fun to learn about coding, and so I decided to start teaching a bit about it. And the reason why I do this is because these days a lot of us are consumers of technology, but we're not really innovators or digital makers, and I want to encourage more people to get involved in doing things with technology and being creative with technology. Also, our district's for students to be college and or career ready, and I want more of our students to be ready for the best jobs, many of which involve coding. There's a study by USA Today that indicated that by this year there'd be over 1 million unfilled computer science jobs, and so it's a field where there's a lot of demand, and also many of the highest paying jobs out there that are oftentimes not computer science jobs still involve some level of coding because so many of the devices that we have these days are programmable. So my goal is that when our students are in a job interview someday and someone says, can you do some light coding as part of this job? I'm hoping they will have had some exposure to coding and that they'll know that they can learn it, and they'll just say yes and get the job. Another data point, locally at CSUMB, there's a 3-year computer science program. Over 70% of the graduates have a job waiting for them upon graduation, as opposed to about 20% is the national average. And I read a research-based article from published by Google about computer science education. And the one thing that really struck me in reading that article was their studies found that if a teacher or a parent even tells a student that they'd be good at computer science, it increases that person's chances of going into computer science by 200 to 300%. And since a lot of computer science jobs are starting out at around 100,000 a year, it's just one more avenue of success that I want to encourage more of our students to go into. So my goal here is to help you take one more step towards becoming inventors and innovators and digital makers. And I'm hoping to raise your awareness about some of the resources out there so that you can point students in that direction. Some of you might end up doing some coding in your classes, but even if you don't, I think having a greater awareness of the resources will make it easier to help nudge students in a direction that will lead to success in their life. I put up this slide mostly just for your future reference. We're not in the middle of a big project today, but I just want to kind of refer you to the idea of design, or the design process, which is basically, starts with, discovery, defining a challenge, and then moves on to kind of a brainstorming phase, and then a phase where we start working and building something, and then then we test it and improve it, and then we share it with others, and kind of repeat that process. I well, I'll tell you a story real quick related to that. Here, I'll switch to. I'll let you see me while I tell the story. Wait. Oops. Okay, we're back to my face. I don't know, I just see Steve there. Doesn't matter.
Yes.
A number of years ago, a science friend of mine gave me this gigantic, huge light bulb, probably like a foot long or so. And I was thinking, what am I going to do with this huge light bulb? And then it occurred to me to make a good idea light. And I'd seen a talk by somebody about the difference between a good idea and a concept and a creation. And they basically said good ideas aren't worth much. People have good ideas all the time. But when somebody builds a conceptual framework around that good idea and then takes all the steps to execute it and bring it into being, that's when it's really worth something. So just thinking of having a good idea light didn't really mean much, but my concept was to connect my good idea light to a solid state relay controlled by a programmable microcontroller with a radio link from a programmable microcontroller that I had up my sleeve, with a little tilt sensor that would send it a signal when I tilted my arm at the right angle, pointing to my head, and make the light turn on. And so I demonstrated this for my class. It was pretty fun. But the part that I wanted to kind of explain to him was there were bumps along the road. There were not only did I have to kind of think of how this was going to work, I had coding errors to work out. I had, broken parts that I had to figure out, what was broken. It took several tries to make it work. And that's the kind of process I want to encourage our students to go through. Okay, so going back to the slideshow. Screen. Okay. All right, I'm getting a little faster at this. All right, so it put me back at the beginning. Here, I'll click. Oh no, it didn't. Okay, design process. So here's some icons. These are just I want to today what I'm going to do is I'm going to give you a super quick overview of some of the resources out there, and then we're going to delve in a little deeper and spend a bit of time exploring the code.org site, which is a great place to direct students for an hour of code. And then I also wanted us to play around in a little more depth with a thing called Tinkercad, which is for developing three-dimensional models. I think the math folks especially think this is pretty cool. But one of the things I like about their site is we can create code blocks to draw things using code and create structures that would be difficult to create just drawing in Tinkercad itself. I also wanted to, the Raspberry Pi is one of the things I wanted to show you really quickly, even though I could spend 10 hours just on the Raspberry Pi. But it's basically a $35 computer. They have some more advanced versions of it now that cost $50, $75 with more RAM in them. So the older version, although it was a complete computer that could go online and do all the things that our Chromebooks or desktops do, it was a little bit slow, which for $35 you'd kind of expect that. The newer versions for $50, $75 have a lot more RAM, and they're about on par with a desktop computer. Let me see if I can show you this little video real quick. It's only about 3 minutes. It's a little cheesy, but it'll give you a quick overview of what the Raspberry Pi computer is. Let's see if it's actually taking me where I want it to. That link used to just go to the video, but instead it took me to the site. Okay, it doesn't. I'm not seeing the video that I actually wanted. Here, I'll try this one real quick. Okay, I'm going to go ahead and pause it at that point.
Writing's not that easy, but Grammarly can help. This sentence.
Sorry about that. Okay, so can you see? Are we back to where you can see me?
Yes, we can all see you.
Okay, so that showed basically how to get started setting up a Raspberry Pi. It wasn't the video that I wanted to show, sort of explaining what it was good for. But if you can see, this is a little Raspberry Pi computer, and one of the things that's novel and unique about this is first of all the price point, because there's things that we can do to experiment with a computer that could cause it to become non-operational, and we wouldn't want to encourage students to do those things, with their desktop computer that costs hundreds of dollars. With something like this, though, we can encourage people to do experiments that might make the computer become dysfunctional, and then we could just reformat it and use it again. But if we damage it, it's only a $35 device. Instead of a hard drive, it's got a micro SD card to run it. It comes without a monitor, mouse, or keyboard, so you just plug in your mouse and keyboard through USB ports and a monitor through a HDMI cable. And one of the things about a Raspberry Pi that's extra cool is that it has these pins on the top that are called input-output pins that allow us to connect the Raspberry Pi to other devices and use it as a platform for inventions. So it's a pretty cool device. The other thing about this that was pretty great is the community and the Raspberry Pi Foundation that creates a lot of activities and projects to do with the Raspberry Pi. So here I'm going to switch back to presenting. Oops. I feel like I'm talking too slow here. I want to get to the activities. All right, so it's cheap. It's so I mentioned before they came out with a newer version of it that's faster. That's the Raspberry Pi 4. And here's just a quick screenshot of the Raspberry Pi website where they have projects. And something that I thought was pretty cool about this website is that it's not just about the Raspberry Pi. They have a number of other technologies that they have good tutorials on. This is where I became aware of Tinkercad, and it's also where I became aware of another device that I'm a fan of called the Microbit. I'm going to be exploring Trinket with people tomorrow, and a number of the activities on the Raspberry Pi website link to this site called Trinket, which is basically a online platform for writing computer programs, and it hosts a number of different languages. You can create websites from this site from scratch, and a number of the activities from the Raspberry Pi website utilize Trinket as a resource. So I'll come back to that. The other thing I want to show you real quick is called a Microbit, and a Microbit it's not nearly as awesome as a Raspberry Pi computer. It's not a full-on computer by itself, but it is a programmable device. And one of the things that I like about it is there's virtually no setup. With the Raspberry Pi, you gotta got to download an operating system onto a SD card. You got to plug in a mouse and a keyboard and a monitor. With a microbit, you just plug it with a USB into your Chromebook or your computer, and you can immediately start programming this device. And it comes with a 5x5 LED array that can display simple things like letters and little pictures and numbers. It's got the 2 programmable buttons. On the edge at the bottom, those are called input-output pins that you can connect other devices to, sensors or motors, things like that. And then inside it has a number of sensors. It's got XYZ accelerometers. It's got magnetic sensors. It's got a temperature sensor, light sensor. It also has Bluetooth and a 2-way radio that can communicate with other microbits. So you can program one microbit to send signals to another microbit. So microbits are something I've been using a lot to introduce students to coding. Let me switch to camera so I can show you one real quick. So here's see if I can do this without everything dropping. Here, maybe. Here's a microbit. I have, remember that bottom edge that I said you could connect to things? A number of places have made these little connectors to make it easier to connect it up to other stuff. But that right there is a little microbit. These cost about $15 or $16, which is pretty cheap considering all the sensors and things that are in it. And they were created by in collaboration with a bunch of major corporations that made this device in order to encourage students to learn more about programming and technology, which I thought was a nice thing for them to do. I hooked one up here. I'll see if I can get this to work on screen for you. I 3D printed this this little mechanical hand, and then I connected it to a microbit, telling the motors on the hand whether or not to move. Okay, and things like this. I don't know why, but technology's shy. I feel like when it's on camera, it's less likely to work. But okay, can you see the hand?
A little higher, please.
Better?
Yep.
All right, so it's going through right now, and it's I programmed it to count in sign language, but it's the microbit holding the code, delivering the signals to the servo motors, telling them how to move. There is also here, I'm gonna unplug this. Won't spend too long on this device. Here's a little robot. Again, this just has a microbit on top, and then the microbit tells the robot when to move and read sensors. It might be attracted to light or be controlled by another microbit sending it a radio signal. I made a bunch of these with the engineering teacher at my school, and so that was a fun project. So one more thing about the microbit. I'll go back to the slides. I keep forgetting to share before I go back. Okay, there we go. Post. Now I'm I'm noticing some stuff posted in the links, and I'm not really keeping up on that. So I'm gonna just let Steve interrupt me if there's anything I should stop for.
I lost the chat for a minute, and I don't have anything on mine right now. So hopefully someone else could take a look at those, Bill.
Okay, if someone else wants to let me know if there's something in the chat line I should respond to, I'll do that. All right, so so that was a quick introduction to the microbit. It's a great resource. I would encourage lots of people to get it. There's a site called CodeHS, and I don't know if our district still has a subscription to it, but in the past we did, and anybody with a SUHSD email address could create an account for it. So they and it has a lot of different lessons about coding. Some of them are a little more basic than others, but if you want to learn more about coding, I encourage you to try going on and see if we're still active on that. If so, it's a pretty extensive resource. So So the link's here if you want to come back to that at some point. Also, like if you have students you're trying to figure out something to do with, there's a lot of things here that would keep them busy for a long time. Okay. I also want to kind of point you towards Khan Academy. They have little coding classes. Basically, they'll have a video where they'll go through something, and then they have little exercises. And primarily, the content they have on there is for the Java programming language and for website stuff, how to program in HTML and CSS. CSS is how you make HTML is basically the content in the website, and then CSS is the styling, the font and backgrounds, and where you place the content of the website. I don't know how many of you have iPhones versus Android phones. This is a really neat resource, but unfortunately, it only works on Android phones, and it's a resource that MIT invented for people to create their own phone apps, and it's pretty extensive. You know, you can tap into Google Maps and the sensors within the phones and a lot of other things. There's a little bit of a learning curve, but if you go through the tutorials, you'll get the hang of it. And there's another one we could easily spend 10 hours and just on this alone. But I just want to make sure you know it's out there because it's really cool, and you might want to come back to this at some point. This is one of the ones we'll spend some time exploring today, which is a website called code.org. They have a lot of, you know, kind of 1 hour coding activities, and some of them are sort of easier than others, but some of them are pretty good. So we're gonna, when I'm done talking, we're gonna go through and we'll be exploring the code.org site on our own, and then maybe sharing the favorite things that we came across. Tinkercad, I think I kind of mentioned already. This is the other thing that we're gonna spend a bit more time on today, and you can generate 3D forms in it, but then you can also generate those forms using code as opposed to their usual editor. So we'll come back to that, and I think, okay, I'm just clicking forward a little bit faster here to see. Okay, so we're gonna go back and actually start working with Tinkercad now. I was thinking of doing code.org first, but I think I'll cover Tinkercad first because it's going to take more explanation on my part, and I know it's usually better to do the more concentration intensive things at the beginning. So let me open up a new window. It might already have me logged in, but if you go to Google, for some reason my default browser went over to Yahoo, which is really annoying. So I have to actually do a search for Google to go to Google. All right. So if you go to Google and just type in Tinkercad, it'll take you to the website. So here's Tinkercad, create 3D digital lessons. And I was going to try to take you to the login page, but it remembered me and it just logged me on automatically. But when you go from Google to the site, you should go to a login page. And then, like with almost anything else, you're going to have to put in your email and create a password for yourself, which should only take a few minutes. So let's do that now. Can everybody go ahead and switch over to Google and see if you can bring up Tinkercad and then put in your email and make a password for yourself and log on.
Should we just use our account? I sign in via Gmail.
Yeah, if it'll let you just sign in from Gmail, that's fine. I always like to I always use my school email for things like this when possible. So you're already logged on?
Yep.
Okay, let me do a.
I'm now in create new design.
Okay, so we got one person logged on. Everybody else, can you? I want to do a quick check-in with you and see if you're logged on. I don't want to leave people behind. The dog's got it. Okay, I'm looking at the chat bar here. Looks like Jennifer, you're in. Looks like maybe you've used it before. Cardo's in. Bishop's in. Okay, Jonathan's logged on. All right. Anybody having trouble logging on? Okay. Maria's in. Okay, good. It's going pretty fast and easy. Another thing about Tinkercad is when you make something in Tinkercad, you can create an STL file and print what you made on a 3D printer if you happen to have access to a 3D printer. So that's pretty cool also. All right, I'm going to go back to present. Does anybody having still logging on that needs me to wait? Please just type something into the chat bar and
I'm still trying to get in.
You're still trying to get in? Okay,
Yes.
we can wait for a couple minutes.
You could go ahead. I just wanted you to know that I'm just realized I do have an account, and now I'm trying to figure out how to get into it.
Oh, it'll have a thing there to change your password and then just go to your email.
Okay.
Like with most accounts. I have that same problem a lot too. I'm getting better about using an app on my phone to keep track of all my passwords.
I don't know. It's now saying I don't have an account, so you guys go ahead and I'll see what I can do.
Okay, I can always circle back, and if you're still having trouble, I can go over stuff with you again as I have other people sort of practicing on their own.
Cool.
William,
Thank
I'm
you.
sorry. Can you show us the home screen again? So just to make sure that I'm in the right spot.
Yeah, that you're at Tinkertag. Yeah. Back to present. So it should look something like this. Is this what you're seeing?
Something like that, except for the Lego pieces.
Oh, okay. Yeah, the Lego pieces are just things that I had created in Tinkercad.
Okay.
I made like this one. I made myself a little battery holder for a little AAA battery case. Here's a I'll show you a couple of these real quick. Here's one that I used using code blocks, and I used it to create little like patterns. So you can see there's that little flat thing, and it has a little geometric pattern on the surface. My wife said basically that this was a coaster, but since I used code blocks to make it, I called it a codester. All right, I hear that's called a dad joke. Okay, so I'll go back out here. Before I show you the coding part, I want to show you basically, what Tinkercad is and how it works. And by the way, see this little block that says Tinkercad? It was not intuitively obvious to me. If you want to go back to their main screen, you click on this block. This is kind of the starting screen here. So I'm going to go to 3D Designs and hit Create New Design. And so this is my workspace for putting three-dimensional objects, and there's a number of kind of regular geometric solids over here. So if I just grab one and I drag it over to the workspace, then it's where I can work on it. To look at it from different angles, if you hold down your the right button on your mouse, I hope you have mice out there. I forgot to tell people that ahead of time. Anyhow, if you hold down the right button and drag it around, you can rotate this and move it around. If you move the scroll button, wait. Sorry, I'm having trouble orientating. Okay, there it is. At first, my scroll button was using the scroll button. you can make it bigger and smaller. And if you press down on the scroll button and move your mouse around, you can move things left and right without rotating it. Okay, so those are the main ways you navigate around your drawing. Probably the most one I use the most is holding down the right button and rotating things around. If you click on an object, you'll notice there's some numbers over here. This cube has a length of 20, a width of 20, and a height of 20. I think those are millimeters, but I would have to double check. If I change this to 2 and hit enter, now it has a length of 2. So you see I've changed the characteristics of my little block. I can make it like 2 by 2, and it's still 20 high. I can also, here I'll hit Control Z a couple times and go back to my original blob. You can also click on an object and you can grab one of these little squares and you can stretch your object. So you can change the shapes that way also. And then notice there's a little arrow on top. If you click on that, you can move the object up and down through the plane. I usually like it to just be on the plane. I'll hit Control Z to hopefully put it back. Okay, so that's basically how you change the dimensions. You can also you can change the color, and the other thing is an object can be a positive or a whole. So it can be a solid object or it can be the opposite of a solid object. So to demonstrate that real quick, I'm going to drag a cylinder. Sorry, I left it. Here I'm going to put a cylinder out in the same space. And the ones that are gray are actually holes, but if you took a solid cylinder and clicked on it, you can change it from a solid to a hole. So here I'm going to make my hole taller, just to make sure it's taller than the block. And if I put this hole on top of the block, I'll get rid of that one. And I click on my mouse and select both the hole and the block. There's a thing up here called group. And if I select group, it combines those two objects. So I can either put two solid objects together, or if I put an object and a hole together, I can cut holes in my objects and modify them that way. Here's an example of here I'll combine these objects and turn them into one object, two solid objects. All right, so everybody with me so far? Can't see the chat bar here. Okay. This is for 3D modeling. If you were a pro, you would not be using Tinkercad. You know, so there's a lot of things where if you tried to do something complicated in Tinkercad, it'd be more difficult than if you tried to do it using a different software. But for getting started really quickly, you know, this is the easiest thing to learn that I've seen, that you can actually, you know, you can actually make something and you can print it out on a 3D printer, or just kind of explore geometric forms in this way. You know, one of the things I like about this is, you know, so this is for you math teachers. You know, if I was to take a cone and I'm going to make this cone a little bigger. Let's go height of 40. Okay, here I'll just stretch it and make it. Oh no, not like that. Control Z. Okay. At any rate, here's my cone. I'm gonna pull a box out into this space. You can also rotate objects. And I'm going to make my box a little bigger here. I'm gonna make it say 50, 50, 50. Okay, so I've got this large box in space, and I'm going to take this box and basically use it to slice my cone. group it together.
Excuse
Okay.
me, what's the special code for it to go through the shape, like the transparent one?
You're switching, things can be a solid or a hole.
Ah,
And it's a hole. A hole is the one where it goes through it, and then if you group them together, it cuts that hole through the shape.
okay.
So-
Okay.
So I did not do a very artful job of slicing my cone here, but what I wanted you to notice here is this is one easy way to create virtual conic sections. So you could tilt your box hole shape into different angles. If you cut it flat, you're obviously going to get a circle, and then cutting it at sides, you can get the other conic sections, which is kind of cool. All right, so man, I'm slow. So I'm gonna move on now. Now that hopefully you can play around with this for quite a while, but the goal here was to move on to coding. So I needed you to at first have a concept of what Tinkercad does before we code in Tinkercad. So any questions before I move on to the next phase? Okay, I'm gonna take that silence as being that we're all good. All right. So again, I'm clicking on that little block that says Tinkercad because I want to go to the main page. And by the way, it's not what I was going to focus on today, but they have a little thing here called circuits, and you can create little like electrical test circuits using Tinkercad also. But we're going to go to code blocks, and this is probably a number of little code block examples that I've made in the past. Let's hit we're going to hit create code block, new code blocks, and they're going to have see this quick start guide. If you come back to this at some point or have students working on this, you might want to go to the quick start guide because they'll have a few little examples that help show you how to get started. Oh, now I'm not sure how to get out of the examples. I'm going to click through this, but they kind of explain how the coding system works for Tinkercad blocks. They also have a couple simple examples to show you the process. I'm not going to read through all these because I'll just show you and click through so I can actually get back to where I was. It doesn't want me to go back. I'll go back this way. Okay. Back to code blocks. Create new code blocks. New design. Okay, so on the left, there's a selection of basic shapes we can use, and then there's ways we can modify those shapes. There's control, and as far as programming goes, the main element this uses is repeat loops, and also repeat loops with indexing, which means you can use the number of times the loop has been repeated as a variable, and then you can create variables, and there's some basic math functions here. So the main concept is a program executes commands in a certain sequence. So if I were to drag a block out into my programming space here, I can click on this arrow to see the details, and I could change parameters here. Maybe I want this to be, instead of 20, maybe I want it to be 10 by 10 by 2. Over here, all this is going to do is place one block on the screen, and if I hit play, it'll go through and do that. And see, there's my little block that's 10 by 10 by 2. One thing I want you to notice here is in code blocks, when it places it on the plane, it centers it on the plane. So half of that block's below the plane and half the block's above the plane. And I usually like things to be on the plane. So the next thing I'm going to show you is how to do a move. So I'm going to add a move block, and the plane, it basically is on the z-axis. Up and down is the z direction. So I'm going to move this up a +1, and since that's half the height of the block, that should put it exactly on the plane. So now if I hit play, I created a block and I moved it up by 1. See, there it is. All right, so now the next thing I'm going to do is I'm going to create a hole. I like little ring spaces. So I'm going to create another. Instead of 10 by 10, I'm going to make this one a little smaller. I'm going to make it 9 by 9, and since it's just going to cut a hole, I'll let it be nice and big. 20's like huge. It'll go through the surface in both directions. And I got to select here to make it a hole, not a solid. And if I want those to join together, before I had to hit the little button to merge them together and create a group. Now I have to add the command to create a group. And before I start, I'm selecting this block called create object, so I can refer back to it in my code. So let's real quickly just run that and see what it does. All right, so now I've combined those two shapes and I've made this little square ring. Here I'm going to make my ring. I want mine to be skinnier than that. I'm going to make a skinny ring, 0.5 in height. All right, so there's a little skinny square ring. Okay, so now here's where it gets a little more interesting, I think, where we can use actual code to do things. So now I'm going to take another loop, and I'm going to use an indexed loop. So in computer programming, we can have a loop do something a certain number of times. We might have a loop do something, say, 10 times. The index is the number that holds the value for which time we've gone through the loop. And that can be useful oftentimes. So I'm going to use that to manipulate this. So within my loop, I'm going to add a copy of an object, and it doesn't know what object I'm copying, even though I've only made one. So I have to scroll down here to where it says data, and I'm gonna, oh wait, I grabbed I. That first object was object 0, so I'm copying object 0. Let's change colors so we see it. It's different. And from 1 through 10, I'm gonna add that object. Now notice if I run this, it's going through it right now. We see it as green, but it's basically going to look the same when it's done. I can also speed this up, by the way. There we go. And so when I'm done, all I see is this green object that looks like the first one that was red. That's because it stacked the exact same object on top of the other one. So I can't really see it. So what I'm going to do next is I'm going to manipulate this as I go. So I could move it, or I could rotate it. I could change its scale as I go. In this case, I'm going to rotate it. So each time I add the new object, before I add another one, I'm going to rotate it around the x-axis by some degrees. And I want it to index to the number of times it's gone through the loop. So I'm going to need a little bit of math to do that. So I can come down here. I'm going to grab this function. It says plus right now, but I'm going to change it to multiply. And I'm going to grab from data I, and I'm going to multiply it by 18 degrees every time. 10 times 18 is 180, so that just seems like a nice number. So rotate by I times 18 degrees. The first time through this loop, it's going to rotate by 1 times 18 degrees. The next time through the loop, it'll create another object and rotate by 2 times 18 degrees and so on 10 times. So let's watch this. And so now you can see we've created a geometric form here that if I were to try to build this in Tinkercad by hand, it would be difficult to put this together. But within code, it becomes pretty easy to make complex forms. I can experiment, do it around a different axis. Okay, that's pretty close to the same. Let me do it around the z-axis. That's a mystery. Ended up in the same place. I'm not okay. I'm a little confused, but I can figure it out later. But let's just stick to one of these. Okay. I could also, so that's moving it. I could also scale it as I go. Say each time I go through it, I'm going to rotate it, and I'm going to change the scale by some factor. And here I'll just have that factor be I. We could scale it in all directions or just one direction. I might want to change this to be I divided by something, but it's gonna get really big here. Okay, my drawing's gotten out of control. Here maybe I'll use some math again and scale that back down. Each time I can change it by I'll say I times I times 0.2. And by right clicking, I can duplicate my code. Oops, wrong part. I'll leave a z as 1, just see what happens here. I zoomed way out before because it got so big. I gotta come back. Okay, so there's that basic shape, but also with some scaling, distorting it more. All right, so let me come back to.
That is super cool, Bill.
I'm glad you like it, Steve. I was thinking you'd like that.
Oh,
So
I'm using that.
So based on what I've shown you at this point, do you feel like you're far enough along that you can start experimenting a little bit? I always like to show people things and then have them play with them a bit. So now I thought now would be a good time to for people just to experiment for a while. What do you think? Do you want to work on your own for a bit, or do you want me to keep playing around with it while you watch? Sounds good?
I'm actually enjoying following along with you, Bill, because I kind of get to see all it can do.
Okay.
Yeah,
Well,
if it would be nice if we can go do it together. Like you show it to us, we'll follow, and we'll do the tricks together.
okay. Let's do that. I'll go back out to present mode, and then you can just switch back and forth between the presentation screen and your Tinkercad screen, and we can try to build up some forms.
Yay.
Okay, and then wait, there's a question here. How do you border the plane? I'm not sure I have an answer to that. My dumb dad joke me wants to say I like using a causeway, but but I'll try to be more serious than that. Let's see. Can you elaborate a little bit, and then I'll see if I can figure it out.
I'm a theater arts teacher, and we build sets. So I can see how this could be a great opportunity for kids to start designing their own sets for theater.
Nice.
And oftentimes we have walls, right? We have walls, and for me to give them a space that I want them to use. How would I go about putting a border around around the place that I want them to build in? Like, for example, if they want to build walls and they want to show me that piece. You showed me immediately how to make furniture and things like that, or objects that look like, we can put. But oftentimes we need to get a set so that we know how to build it. The kids can imagine it.
Right,
And
you have a certain amount of space. So you want to define what the stage space is, basically, right?
Right. And so sometimes they're square, sometimes they're they're rounded, or they're rectangular, and then then there are times I have a set that is maybe rectangular but thinner, and then I have another space, another set right below, like on the audience floor or in front. So I'm going to want, it'd be nice for them to be able to put it all on one plane, so that when you look down, you could see where, down stages, upper stages, and where things are going to be happening.
Right. So there's two things there. I'll switch over and I'll show you. One is, if they're looking down, you can create something in three-dimensional space that might be at different levels, like you said, and then to look down on it, you could change your view and view it from a different angle. But the other thing I want to show you is you could define your set space, and there's a way to save that as like a special object as opposed to a cube, and then I think you could share that, and then students could just pull that out, and that could be their starting point that they design.
Oh, that's cool. Yeah.
So here,
that's really cool.
Let me switch back to that.
I also really like the fact that you can go below the plane. So if I have for example, a set that has stairs, like an upper room and a lower room, I could design it that way.
Okay, let me show you real quick, and then I'll go back to examples with coding in the space. Okay. There's certain things that I'm not very good about doing when I teach workshops, and one of them is giving breaks. So technically, if you stick with me here, you're working for the next 15 minutes for free, because technically you're on break. The other thing I'm not very good about doing is setting norms. I tend to never establish norms. I just hope for the best, because I know everyone's so nice, so I'm not that worried.
William, everybody got a break after rehiring.
Everybody got a break?
Yeah, everyone got rehired.
We all got rehired. That was our break. I'm glad we all got rehired. I'm going to leave the coding section, and I'm going to go back to just the drawing section to answer that last question. So
I hope I'm not taking you off track. I just wanted to explain what I meant. I didn't.
No, it's okay, because I think I can show you this real quick, and it's also something I'd like to show everybody else anyway. And I get myself off track constantly, so I'm fine with that. So here, I'm going to start with a rectangle, and I'm going to drag this out to create. This is basically my stage space. Okay. And what I'm going to do is I'm going to put a hole over this to kind of create like an outline. I'm going to draw this a little sloppy, okay? You know, in reality, you might want to, you know, you'd probably do a much nicer job of this, but I'm going to do a real quick version. So see, that's my stage, and you could change these dimensions however you want. Mine's 144 by 145. And here I'm gonna make this, the height, really small, so it's more of an outline than an object. And then I'm going to combine those two so that I've so that there's like a little outline to delineate where your space is. And if you wanted to, you could do the same thing with adding on, you know, curved sections by merging with like a cylinder or something.
Got it.
But once you get it just how you want it, here's the thing that I wanted to show everybody. Under Tinkercad, there's basic shapes, but there's also some other cool stuff here, like characters. How did I end up? Wait, I'm looking for my letters and stuff. Okay, I got glasses and other funny stuff here. That's not what I was thinking. Text and numbers. Okay, so here I can bring over some text here, and if I want to, I can.
William, let me cut in. So can we also do animation with this?
Not that I know of, but that could just be because I don't know as much as I might. I'd have to look into it. Not as far as I know, you don't do Tinkercad animations in Tinkercad, but I could be wrong. It does animations when it's like building. You can save like a Tinkercad code design, and it'll display it as an animation. But I don't think this part's set up for animation. Okay, so the other thing I wanted to show you here was you can basically save this. Let me see if I can find the right printables. Favorite parts collection. Okay, so create shape, and it wants me to make sure I select it first. So here I can select all that, hit create shape, name the shape, stage left, and then I can save that as a part. So now every time I start to create a new, something new, I could just bring this into my space as a part. And so your students, you could share this with your students, I think, and then or have them just do it once, and then they could reset up their stage multiple times and not have to set up the outline over and over again.
Cool. Now, could I also take that and paste it into like a Word doc or a Google Doc if I just wanted the image?
To put it into a Word or a Google Doc, I think what I would do is just simply get it on the screen and then do a screen capture of the image.
Oh, okay.
Usually, when you're exporting, you can export it, I think, as a 3D drawing, a .obj.
Got it.
But the other cool thing is if you have access to a 3D printer, you could print these things out after you make them.
That's cool.
Okay, so back to the coding part. And then timekeeping wise, we're kind of halfway through, but that's okay. We'll spend less time at the code.org site. So I'm going to go back to code blocks and create new code. New design. All right. And so at this point, I'll just experiment around a little bit, and I'll have you follow along with me. And And I'll be honest, I haven't used Tinkercad in a while, so I might be a little rusty, but hopefully I'll do okay here. So I don't know why, but I'm partial to manipulating ring shapes. I like little flat rings and then doing things with them. So I'm going to do a ring instead of a square ring. I'll do a circular ring. So I'll start by bringing a shape out, and I'm going to make it short again. So I'll just do one high, and then I'm going to define it as an object right away, because that way I can call it back and create multiple versions and do things with those versions. And like before, I want to make a cylinder, but I'm going to put a hole in it. So how about I'll add it to another cylinder, and I'll make my other cylinder a little smaller, maybe 9.5, and I'll leave it tall, make it a hole, and then coming down here I can merge those two things together by creating a group. And also I like things to sit on the plane, so once again I'm going to move that first one up by 0.5, because that's half of 1. And that should give me a little ring on the surface. Okay, so there's a little ring to play with. And then let's just experiment with that a bit. So how about I'll create a new object where I'm going to take copies of that and do something with it. And here again, I'll use an index counter. I'll copy the object that I started with. Create, add. Oh, there it is. Oh no, I wasn't seeing copy at first. And why is it not? Sorry, oh, there it is. Add copy of object. I grabbed copy instead of add copy of object. As you probably noticed, if you don't want a command, you can put it in this garbage can over here. So I'm going to copy the first object I made, object 0. I'll change the color so I can see, and then I'll do something to it. How about I'll just move it for now. So each time I go through, I'm going to move this by, I want to use my index, and I need to use my index variable. How about I plus 5? That'll start overlapping them. Put it in the next direction, and we'll see what it did. So 5 didn't move it very far. Thought it'd move farther for some reason. Here, I'm going to change this to a little more. I'm going to go I plus 10 and see where we're at. Oh, I see, because it's incrementing by 1 each time, right? So do you see that the first time it moved it over 5, and then each copy it made was only moved over 1 more. So it went 5, and then it went 6, 7, 8, 9, and so on. So now if I do this again, it's basically going to be the same with all these ones squished together. It's just going to move it to the edge instead of the middle. So here, let's just look at what it does. Okay, and kind of what I was picturing here was something where the rings were overlapping each other as they spread out, not all scrunched together here. So what I really want to do is I want to multiply this by 5. So I'll do I times 5. And now I'm starting to get rings that are overlapping each other. One of the things I play around with this on is creating you know, textures and patterns that I can print out and then push clay onto to create designs on clay. Now I'm going to do a loop within a loop. So if I do another loop, it's gonna, the index name's now J instead of I, and I'm gonna try placing this loop inside this loop. And I'll kind of copy this bit of code, put it between loops, and I'm going to move this in the, instead of the X direction, I'm going to stagger it in the Y direction. All right, and hope if I did this right, hopefully we should get more of an array now. So I'm making copies in 2 directions. Okay, and it said I got too crazy. It's also not doing quite what I wanted it to here. I have to reinvestigate my code. I was kind of picturing something spreading out and getting this in 2 dimensions. It's let's see here. It's moving over, but here it's always going back. So oops. This is that iterative process I talked about before. Well, I don't think that's going to be quite what I wanted, but I'll just play around. So now, right now, it's making a line. It's just staggering in 2 directions, and it's getting it's going at a diagonal instead of straight. I'll keep thinking here. Could be I'm making things too difficult from from the get-go on myself here. Okay, each time it goes through. All right, well, I'll have to come back to this one. Let's play with scale or some of these other things first. Maybe rotating. So each time I can move it a little bit, but I could also rotate around the axis by some.
William,
Yeah.
could you scroll up to see the 4 steps at the top? Because I'm not getting the ring. It just keeps staying solid.
Okay, yeah, right here. So it created an object, and then I had to create a hole. So when creating the other object, I had to make sure I selected the little gray part here, so it would be a negative of the object. And then I stacked it on top of it, and then combined the two.
Oh, okay, yeah, I got it. Thanks.
Yeah, you probably didn't click on the hole, right?
Correct, I did not.
Yeah, I've done that too. Okay. I'm trying to think of what else to do here to play around. Here, let me go back and look at some of the ones that I made in the past. Go back. And then I should probably take you to the code.org site. That was the other half of this that I wanted to do.
Question real quick. How do you
Yeah.
merge the two? If you have two different objects, how do you mix? How do you put them together?
How do you put them together?
Yeah, like the okay, yeah.
From the coding area, or from like the space for the Tinkercad, that I showed you initially?
From the Tinkercad, where do you go with the controls or the math part?
So the part where it's code block, or the part where we're just drawing?
The code.
Okay, here I'll show you. I went back. I started heading
I'm
back
sorry.
to the part. So
I was
let me-
trying to manipulate and I'm thinking of something, but it's when I press play, it's like one at a time. I want to merge the two of them.
Okay, I'm just going to show you both anyhow. So here's how to do it from just the drawing area as opposed to the coding area. And to do that, you select both of them and you hit the merge button, and now they're joined together.
Okay.
Going back to the code blocks. Okay, code blocks. I wonder if this is the one I just was doing. And so back to the code blocks, what you have to do is you have to put in this create group block.
Oh, how do you do?
And it's down here. There's create object, add object. At the bottom of the purple ones is a create group block.
Oh, right there.
And so that'll combine everything together in the same object.
Okay. You don't mind me showing what I've done, and so I can tell you what I'm thinking of doing, and then you can tell me what to do.
Sure, I'll try to. Go ahead and tell me what you're thinking.
I'm gonna share my screen real quick so you can.
Okay,
you can,
let me stop sharing my screen.
I don't know. I just feel like sharing. Let's see. Oh, just a window. I'm sharing your face. Like, so I've done this, and I want the green and the yellow to move simultaneously.
Green and the yellow to move simultaneously. I'm trying to figure out how to.
I don't know if
I want to make the screen bigger so I can see it better.
Oh.
I remember I learned a way to do that recently.
Because if I'm gonna play, it's like the green first with the code, and then after the yellow. cool.
And you want them to go at the same time.
Yeah, like they can move together.
So basically, what you probably have to do to make things, you have to make it look like they're moving at the same time, which would entail basically moving one by just a little bit, and then moving the other by just a little bit, and then moving the first one by just a little bit, and then moving the second one by just a little bit, and so on. So you have to kind of combine the two motions, kind of split it up. Unfortunately, my eyes aren't that great, and on the screen.
It's okay. It's okay. I'll play around, and then maybe I'll share. I'll ask more along the way. But
yeah,
thank you for looking into it.
No problem. With most things, it's a matter of getting started and then just experimenting a lot. Okay, I'm back in presentation mode. I'm gonna look at a couple of the ones that that are already created. When do we go till? This is to 3:15.
Yes, I think.
And so here's another one. Let's look at it and see. On this one, I created some variables, radius, height, and so on, so that I could change things as variables instead of explicitly. And here, I'll play this one. It's going full speed. Just kind of generating a pattern. Another thing I don't think I'd shown you was there's a step mode. So if it's if your code's going through too fast and you can't quite tell what's going on, instead of hitting the play button, you can hit the step button and have it just do. It can go through the code just one command at a time, and you can see it's highlighting the move that it's on, so you can trace through and see what it's doing and when. So that's the step mode. Here, I'll go back. Has anybody here ever done any like electronics type stuff? On these, it used to show a like a picture here of you could kind of see which one it was. So now I don't know. I don't know what this will be. This is just playing largely with scale, I guess. Oh, and it's going off the page. I'll try another one. Another interesting form. Okay. I'm gonna take a look at some of the other things here. Selecting, changing the size. I think we've kind of gone over enough of this that you could experiment at this point. So I think what I want to do now is show you the second resource that I wanted to have us look at today. Let's kind of switch gears. So here I'll leave presentation mode. All right. So hopefully, do you feel like this kind of like put Tinkercad on the map for you at least?
Yes, it did.
Yes, especially on transformations
It's pretty cool.
and graph.
Before we leave Tinkercad, let me show you one last thing. Just because usually when I do tech sessions, we're in person, and one of the things I like to do with teachers is help them wire up an electrical circuit where they can push a button and turn a light on. I don't know why, but it's always very gratifying to wire up an electrical circuit that works. And since Tinkercad has they have a circuit building simulator, I would like us to build a circuit just because it warms my heart to do so. I don't know why.
William, this is exactly what I need for my engineering.
Nice. Tinkercad's awesome. Do you have a 3D printer for your engineering class by any chance?
Yeah, I have 2 MakerBots.
Oh, that's awesome, because you'll be able to actually print out the stuff that you design in here.
Sounds cool.
Yeah. So here's a little circuit. I dragged out a battery, and I'm going to use a resistor. If you hook up an LED without a resistor, it can cause the LED to burn out. So I don't know if virtual LEDs will burn out, but I'll use a resistor anyway. And I wonder if I left the slide here. Let me
We
go
can't
back.
see it. We
Huh?
can't see what you're doing.
Oh, I'm still getting this whole distance learning stuff down. Going back to sharing. Thank you for letting me know. All right, so here, let me go back to the beginning. So they have circuits, so I can create a new circuit. And I was going to see if I could find you know what, I had it in my slides, but I pulled it out because I figured, well, we're not going to be building circuits. Here let's see if I can find it for you real quick. I just wanted to show you a little bit about the basic concepts of electricity for anybody who doesn't know. So when dealing with electricity, we're really dealing with 3 main quantities, and those are electrical current, electrical voltage, and electrical resistance. And I'll have it in here. And so there's this one little diagram that I like to share that I think helps really illustrate those 3 quantities. And they're kind of put together by something called Ohm's law. And it's a slide here. So when electricity flows through a circuit, the 3 main quantities, like I said, are voltage, current, and resistance. And the current is the electrons flowing through the wire. The voltage is what pushes them or makes them want to flow through the wire. And the resistance restricts the flow of the current, making it harder to flow through the wire. So as voltage increases, it pushes the current harder, making more current flow. As resistance increases, it makes it harder to flow through the wire, causing less current to flow. So the relationship between voltage and current and resistance, called Ohm's law, says that the total current is equal to the voltage divided by the resistance. So that's your quick electrical primer. In a circuit, electricity can basically flow through a wire, through a light, through a resistor. If the switch is closed, through the switch, and then back to the battery. That's called a complete circuit, and then the light would turn on. So, so here in Tinkercad, I'm going to create a simple circuit just for fun here. So first, I'm going to want a battery. Doesn't really matter, I guess. I'll just use this one. And I'm going to connect a resistor to it. I think if you just grab the end and then connect them, then I've done this once before, so there we go. Now it's connected to the positive side of the battery. And I'm going to connect this to an LED. And then I'm going to route it through a little push button. By the way, push buttons they're kind of tricky. There's 4 terminals here. 2 are electrically connected together. And 2 of the terminals collect together when the button's pressed. And I think the 2 that are bridged by the button being pressed are these 2 here. But if I get it wrong, I'll just redo it. And then I'll go from the other side here back to, I wonder if I can, yeah, there we go. All right, now I'll start simulation. And I don't know where I hooked something up wrong, darn it. Okay. Okay, this is not awe-inspiring. I haven't used this very often. I've done it before and had it work, but right at the moment, I'm pretty sure that's not. Oh, wait. Okay. Well, maybe one of these just didn't. The other thing is an
You
LED.
wanna start simulation? I don't know.
An LED can be hooked up backwards, so it's possible it knows that and it's connected to the wrong side of the battery. I'll try one more time and then I'm going to move on because this was just a little side thought and I don't want it to derail what we're doing. Oh, yeah, there it is. Okay.
Right there.
Okay, I turned the light on. Okay, now just because I'm compulsive, maybe I'll use a different switch. For the sake of being compulsive, I just want to see if I can turn it on and off with a switch. Oh, there it is. Okay, there we go.
Hooray.
Switch. So completing the circuit. Okay, I feel better. It worked. All right. So while we still have a little time left, let's leave Tinkercad and take a look at the code.org site.
Yep, I got mine working as well.
You got a light working?
Yep,
Yay!
with the switch.
I don't know why, but it's more satisfying to do it with actual wires and lights and things. Okay, so again, my super annoying computer has made Yahoo my default search, so I'm gonna find Google from the Yahoo search. I keep changing it back, and I don't know. It's annoying me that it keeps doing that to me. All right, so from a Google bar, I'm just gonna go to code.org. And this, for if you want to do like just a little coding, someday, this is a nice place to do it from because there's just lots and lots of little short activities on this site. And I'm gonna hit get started. Hour of code. Trying to find. I was just here yesterday. There's a setting where you can go through and you can search by like grade level and things like that. There's App Lab. Oops. Sorry, I'm having. Okay, there we go. That's what I was looking for. So you can kind of select based on grade level, and so we'll go for the higher grades, I guess. I'm having more trouble navigating the site than usual. Usually, like, they'll pop up with a bunch of boxes with different activities. Maybe it's under projects. Okay, so this is what I was looking for. So here's like lots of different activities and things to do that, take about an hour or so. I was looking through some of these the other day. They had one that was like a music generator. There's some where you do some coding and create designs and stuff. A lot of these are where you use code just to kind of move around in a world. So I'll just kind of randomly pick this one. So here in Minecraft, okay, this is not quite what I thought it would be. This is just letting us move. Most of these you enter like blocks of code to decide how the little character is going to move around. And usually I find a lot more of these. Start a new project. Let's do click categories. So I'm not taking time to read the directions enough, I think. Draw something, your code saved as a project. Move forward. I'll come back to this one. I picked out a couple that I kind of liked. Let me see if I can go straight to those. Here I saved some of the ones that I looked at already that I wanted to revisit. Oh, this one's in
Hi,
Code HS.
welcome to the Music Encoding Exploration. In this video, we will give a quick overview of computer programming and see how we can use block coding to create our own musical beats. Let's jump in. Computer programs are the way we communicate with computers and give them instructions. With programs, we can make all kinds of things from the apps we use to social media platforms to video games and much more. Giving instructions to a computer is kind of like the way a pianist tells their fingers which notes to play and when. But did you know that computer programming is also used in many parts of music production? Today you'll create your own music by making a computer program. We'll be using JavaScript, which is one of today's most widely used programming languages. Let's see how we can use programming to make our own music. We're going to be using block coding to create a beats program, so let's take a look at how the editor works. You'll see this green block titled Song in the middle of the screen. Whatever we drop here will be read by the computer and played in our output screen, shown on the right. On the left side, you'll see the coding blocks library that you can use to create your beat maker with music visualization. See how all of the coding blocks are color-coded in their own library sections? Let's start with bringing in a pink beats block. This is how we'll let the computer know when a sound should be played. To add my own beats block, I need to drag this block so that it snaps into place to my song block. Did you hear that click? If the block isn't snapped in, the computer will not read and load the block. We haven't yet told the computer which instrument we want to use, so we can go to the drum sound section and drag in this little yellow block. We can use the drop-down menu to change the sound and click the check marks to select the beats we want that sound to play on. We can drag in as many pink beats blocks as we want to add multiple instruments to our beat. You can even record a sound by dragging this little yellow UR block in where the instrument would go. You can record a sound by going to the More tab and clicking Upload. Click the microphone button and record your sound. Whoop! Then copy and paste the URL into the yellow URL block. It's that easy. We can also set the tempo, which are the beats per minute, so you want to set it to something relatively high. The tempo block needs to be at the top of the blocks to work properly. Whoops! Instead of selecting another beats block, I accidentally grabbed a drum sounds block. If you ever need to delete a block, you can either drag it to the trash here, or select the block and press delete on your computer. If you drag a block with other blocks that are below it, it moves the whole section of blocks with it. If you just want to delete the top level block, keyboard shortcuts will do the trick. So I can use Control X and delete just that block. If you aren't sure when you want each beat to play, click Run and experiment with your beats by clicking each box to turn the sound on or off. Once you have something you like, you can add it to your program. When you've made a beat program you're happy with, you can alter the visualization of your beat by dragging in these different blocks and selecting the colors you want to show in your beat visualizer. I'm going to set an on and off color by dragging in these two blocks. Let's test that. When you have an output you're proud of, make sure to show your friends and family by clicking the share button. Copy the URL and share it with others through email or your favorite social media site. Feel free to make more than one so you can experiment with different instruments and visualizations. We hope you have fun making your own personalized beats.
Okay, and so I'll hit the continue button. If you come back to this, you don't need to watch the video over and over again. It doesn't seem to let us skip it, but you can just drag the bar over to speed it up till the end. And then here's the space where we could actually start to play with this and add other sounds and notes and things like that. And what I'll do here is Control C. I'm going to drop this into the chat bar so that you can go right to this one and play with it if you want to. And so I guess I was thinking that that was on the code.org site, but that was actually on the CodeHS site. And from, I lost track of my screen.
Where's that music app again?
It was one of the activities on the CodeHS site. And I put the link to it in the chat bar. And now I've lost track of which tab I'm on. Oh, here we go. I'm going to see if I can back out to the rest of the site here. That's odd. Maybe code.org linked me to the CodeHS site. Because usually CodeHS, it has classes and stuff, which I think we can get logged into. But I was looking at more like their short activities before. I'll have to play with that. Let's see. Has anybody tried copying that link and see if you can try that activity?
I did copy. I haven't tried an activity though.
Yeah, see if you can go to that link and you can play around with the sounds a little bit.
Yep.
Is it working?
Yes, it is.
Yeah. Okay. Nice.
I'll be surprised if you hear me on the radio one of these times.
I'm looking forward to it. I actually had a one of my previous students has won a Grammy Award.
Wow.
Yeah, I made her a little Grammy trophy, a little teapot in the form of a Grammy. Okay, I'm gonna put another link in the chat bar to help direct you to other activities. These are CodeHS Hour of Code activities. So I guess what I'd like us to do is play around with the music app a little bit, or some of the other activities here, and then we'll kind of come back together for the last few minutes.
And we need to sign up into it.
On the Hour of Code things, I don't think you have to sign up. I think you can just do them. Yeah, lesson plan. Here, I'll just, I'll try one. I'll switch back to present. So here's the second link I gave you, went to a place where they have more activities. And you can just select from here and play with any one of them for a little bit. Generating art and code. This one on Java, Python. And these have a little bit more in the way of like teacher resources.
Hi, and welcome to the Art and Coding Exploration. In this video, we'll give a quick overview of computer programming and see how we can use block coding to create our own art. Let's jump in. Computer programs are the way we communicate with the computer and give it instructions, kind of like the way a painter tells their brush which strokes to paint and where. But did you know that computer programming can also be used to produce art? Today we'll create our own art by making a computer program. We'll be using JavaScript, which is one of today's most widely used programming languages. You're probably familiar with memes on the internet, like the ones you see here. When we think of art, we probably think of old paintings or sculptures in a museum. However, many people argue that memes demonstrate the expression and creative skill to be considered a medium of art. Let's take a look at how we can use code to generate our own memes. We're going to be using block coding to create our program, so let's take a look at how the editor works. You'll see this green block titled Collage in the middle of the screen. Whatever we drop here will be read by the computer and put onto our canvas, which you can see over on the right. On the left side, you'll see the coding blocks library that you can use to create your program. Do you see how all of the coding blocks are color-coded in their own library sections? Let's start by adding our image. We can use this set background image block if we want to use one of the images that is preloaded, or we can use this block to add our own image from a URL. To add my own image, I need to drag this block so that it snaps in place to my collage block. Do you hear that click? If the block isn't snapped in, the computer will not read and load the block. Since I want to use my own image, I'll go to the Upload tab to upload my own image. I'll go to my desktop, select the picture that I want to upload, and it will generate a file URL that I can use. So I will paste it into this block. This image will automatically fill my entire canvas. Now let's add our text. Instead of selecting the text block, I grabbed a circle block. If you ever need to delete a block, you can either drag it to the trash can, or you can just select the block and press the delete button on your computer. Here's the correct block. Now, my program will place objects on my canvas in the order that they appear in the program. So I want my background image to be the first block, and I want my text to come after it so that it sits on top of my picture. Now I'll set what my text says, as well as the size, position, color, and font. I'll first type my message, and I want to set my font to Georgia. I'll keep my font size for now, but I do want to change the position of the text. The coordinates 0, 0 are located on the top left corner of our canvas. If I make my x coordinates larger than 0, that will move our text across the right side of the canvas. If I make the y coordinates larger than 0, they will move closer to the bottom of the canvas. So I want to set my coordinates here to 20, 400. Let's see how that looks by running our code. I can't really see the black text because my image is dark, so I'll change the color to white. To see the changes, I can just click Run again. That's better, but I also want my font to be larger, so I'm going to change it to 32. Great. Once you are happy with your program, you can click this Share button to generate a link you can send to your friends and family. You can also click this camera icon to download an image file that you can share with others. Now it's your turn. We hope you enjoy making your own meme art.
All right, so meme generator, that's kind of cool. So I'm supposed to direct you to the session evaluation before time's up, which is in like 4 minutes, and I'll place that in the chat bar. Here we go. And who mentioned that they're teaching engineering next year?
I did. I'm the Engineering Academy coordinator, so I have 4 different preps of engineering.
Cool. What site are you at?
Alisal.
At Alisal? Nice. Have you ever played with the microbit before?
I haven't. Everything you've said, everything you showed me, I'm very interested in, and I'm going to be contacting you.
Okay. Are you signed up for the Friday session
Yes.
on physical computing? Okay, nice. Because that's the one where I'm going to introduce the microbit. And a few people contacted me so I could mail them a microbit. Were you one of the people who got one?
No.
Oh, darn.
I get the mail of the microbit. Thank you.
So you got one in the mail? Nice.
Yes.
Robin mailed some out. Yeah, it would have been nice if we could have gotten one to you also. So if you're doing engineering classes, and you have any budget, I'd really recommend getting a bunch of microbits. You know, especially since they're only about $15 or $16, and they make a great physical device that you can code and you can turn into you know, a wide variety of inventions. You know, whether they're robots or just other, you know, just gadgets that do things, because they've got sensors in them and you can program them and they can control the world.
It sounds great. Yes, I'm looking into that, and I do have a budget.
Yeah, I'm looking forward to introducing you to the microbit. Where are you located at?
I'm at Alisal High School.
No, I mean like now, like where?
Home.
I'm just like, I'm curious. Like if we live relatively close, I would drop one off for you.
I'm in Salinas, and I can come to you.
Okay, I'm up. I'm just south of Watsonville.
Okay.
If you want, I'll give you my address and I'll loan you a microbit, but I can also loan you like a little kit with like different things you can hook up and connect to it.
That would be wonderful. Thank you. I appreciate that.
Yeah.
I'll come for it.
Okay. I guess at the end here, let me know. I'll I'll get you my address.
Perfect.
Everybody else, you got the link to the evaluation?
Yes. Thank you so much for this opportunity and sharing your expertise. Thank you.
It's been great having you all here. Any closing thoughts, anybody?
Very helpful.
Awesome.
I have a lot to play with, which is fun.
Yeah, cool. It's kind of a short amount of time. I had to like just pick a couple things of a lot of different things to look at, but you have that presentation, so there's a lot of other resources there. The session I'm going to do tomorrow, I'm going to focus on the Raspberry Pi website, where they have a lot of activities, and then probably the use of Trinket as an online programming platform. And on Friday we'll focus on the microbit. A few people will have one in person they can plug into their computer, but with the microbit they also have an online simulator, so you can create code and then run it through the online simulator to see what it would do in a real microbit.
And also, I just noticed that the Tinkercad has a lot of tutorials built in to
Yes.
the program, which is nice.
Yeah, they have tutorials both for drawing but also for like the code blocks. They have a number of tutorials in there too.
Yeah, cool.
Yeah. Well, I guess that's it for today.
Hey,
See you
Will.
tomorrow.
Thank you.
Bye. Stay safe, everyone.
Yeah, you too.
Hey, Will, I always thought the Raspberry was just for video games, because that's all I have in there. But now I know.
Oh yeah. Go to the check out the Raspberry Pi website, because they have tons of like projects and activities that you can do. And something I noticed about the website is like some of the projects to me, like they seem kind of like juvenile. Like there was a whoopee cushion project where you can make like a little switch out of paper plates and sponge and foil, and then you put that under someone's chair, and when they sit on it, the Raspberry Pi would play back a selection of random fart noises. Which, I mean, whoopee cushions aren't really my thing, but I took the same code and ideas, and in previous workshops, I put one of those little contact switches under the doormat, and then as people would walk into the room, it would yell out like random greetings, through a speaker that I could pre-record. So the Raspberry Pi is neat because you can hook up, cameras and speakers and tie into the internet and stuff like that.
Wow, I have to check it out.
Yeah, yeah. The website will have lots of ideas. Okie doke. I guess I'm gonna sign off here. I'm gonna hold on and get you my address. That's wait, Jennifer, right? Or
Right.
let's see. You all just type my address into the bar here, or do you want me
Sure.
to have you write it down?
Yeah. Actually, yeah, into the bar is good.
Yeah. Since this is being recorded, I'm not sure I want to enter my address into the bar.
Oh, okay.
Maybe I'll turn the recording off first and then enter it.
Yeah.
Actually, I don't think I have control over the recording since I didn't start it. Here, what's your email?
I'll put my email address in the bar.
Okay, and then I'll email you my address instead of putting it in the thing here. Is whoever started the recording still online? I think whoever started the recording might have left, and then we don't have a way to stop the. Oh no, we don't have a way to stop it. Okay, Jennifer Westerbeck. Did we talk a couple years ago?
Very possible.
I was I don't know, 2-3 years ago. I tried to start a technology extracurricular league in the district. there's some interest, and Paul was interested in stuff, and we put together a proposal. But basically, the idea was to have a person, a representative at every school site in the district, kind of like a technology collaboration with like after school activities. And then since we coordinated together, we could like organize like little inter-district robotics competitions and things, and then like come together for events as a district. But they didn't go for it.
Oh.
But I thought that,
I don't remember hearing anything about it.
yeah.
But yeah, I don't have a lot of people to collaborate with. I'm looking for people to collaborate with. So I definitely need to collaborate with you.
Nice. Well, I like technology stuff and engineering type things. Kind of a throwback to when I was a physics teacher, I guess.
Yeah, it's just fun, cool stuff to play with, and that's pretty much what I get to do all day.
Nice. You're lucky to have the job you have.
Yes, I got lucky.
Do you have you developed any system for like, getting materials back and forth to students during the year?
No, obviously, because we haven't gone down that path. But and I teach Project Lead the Way. So I have kits that I have made up. Like I've got soldering kits and I wire walls. So I have kits that are set up for with the tools that they need to be able to wire the walls, and so I think so I teach 4 different subjects, and I have kits that will work in between the so I have some stuff that I can do, that I can deliver or have kids pick up, so that they do have some hands-on things. But I'm actively looking for simulations, and so I think that the Tinker is going to be amazing, because you can do a lot of different kinds of simulations with that.
Yeah, that'll be cool. The microbit also has a simulator, but
Oh,
really,
yes.
I mean, like myself, I think you're gonna want to be able to send materials home, and that's something I'm gonna need to struggle with also, is how, what the process is gonna be for sending clay home and picking up, collecting
Right.
student projects and firing them and stuff like that. And
Yeah.
And
So I'm not sure if I can use my 3D printers. I
well,
have to figure that out.
I mean, for you though, I mean, you could go into school as an individual, probably, I think, and then like a student could just email you a file, and then you could print something out for them.
Yeah.
Or her. Yeah.
Right. Not the same, but yes,
Yeah.
definitely.
Yeah, we both have we both have classes that involve physical things, and I have to figure that out, what the process is going to be to move things back and forth. I'm going to switch screens here, and
What campus are you on?
Salinas High.
Oh, you're at Salinas High. Oh, okay.
Trying to find your email, Wester. There it is. Okay. Okay, so here's my phone number. And oh, darn it. What happened? I lost my message. Oh, it sent it when I was still working somehow. Yeah, I'm just going to start over. Darn.
So I got something from you. The half of it.
It wasn't done yet. So you got the phone number.
Yeah.
You know where Las Lomas is?
Say again?
You know where Las Lomas is?
Yeah, I'm in Las Palmas.
Las Lomas, though.
Oh, Lomas. Oh, no, not offhand.
Oh, okay. That would If you did, I'd just, you would know right where I am better.
I'm in Las Palmas too, if you're familiar on River Road.
That's kind of towards Spreckles.
Yeah.
Yeah. So Las Lomas says, you know where Prunedale is?
Uh-huh.
So if you get off at the Prunedale exit and you come up San Miguel Canyon Road,
Right.
San Miguel Canyon Road dead ends into Hall Road, and then you make a left on Hall Road, which would take you right into Watsonville, basically. And
Okay.
I'm about 5 miles before Watsonville.
Okay.
And along that road, there's basically just you turn left, and then there's next time you hit a stoplight, that'll be Las Lomas Road, and then you make a right, and then a right on
Okay.
Thomas. One thing tricky about my address, if you're not just following a Google navigation in, is even though my physical address is 21 Thomas Road,
Yeah.
the road I actually live on is Emmanuel Court.
Okay.
So you'll be making a right onto Thomas Road, and then the first turn on the left that's not a driveway is Emmanuel Court,
Mm,
and I'm the second driveway on the left.
okay. Well, I will put the address in, but now I know the rest of the story.
Yeah, and just let me know when you want to come by. I'm pretty much around all the time.
You know, I'd really like to come by and pick your brain. Would that be okay?
Sure. I mean, we could also do that, like over video too.
Yeah, like, okay, yeah, see, because you can hand off without us having, we can keep our physical distance and then we could video chat.
Yeah.
I could just see that you can be a great asset,
Yeah.
resource.
Under normal circumstances, I'd have you in the house, but my wife's making my friends wear masks just to come meet me at the gate.
Yeah, okay, that's fair. That's fair. Okay, well, I thank you for your information and I will be in touch.
Okay, yeah. Let me know when you want to come by. Be nice if you had stuff for the Friday workshop, because then you could actually hook things up as we go through.
Oh, okay. All right. Today's Wednesday. All right. I'll bear that in mind and and you gave me your phone number, so I'll probably text you
Okay.
just out of convenience. And it probably won't be today, but maybe tomorrow after my workshop.
Okay. And if you can't make it, that's okay too. You can kind of learn on the simulator, and then I can send you stuff.
Okay. No, I'm very interested. Thank you so much. Very much appreciated.
Yeah, this fun talking to you.
Yes. Yes. Big help. Thank you.
All right. Have a great day.
You too.
Okay.
Bye.
Bye.